Hey folks, welcome back to another question. Today we're looking at question 2140, solving questions with Brainpower. So the way we'll be solving this problem is by actually using dynamic programming. This question is a little hard to understand, so I would recommend going through it and working through a couple of examples before you tackle it. So actually let's get start with the problem itself. So the first thing that you need to do is actually get the length of the questions that you have. So questions dot length, right? And then when you create DP arrays, like if you've done that before, you always try to create it with one size greater, just so that you can account for all the base conditions as well. So it will be n+1, right? And once we have that, we actually iterate through it. But instead of iterating it from the beginning, what we'll do is that we'll be iterating from right to left. So the reason why we'll be doing that is because when we move from left to right, we are limited in the number of steps that we can take. But if we do it backwards, what we could possibly do is, okay, if you solve this question, you already have so many points, and then from this question you can go back. So that way, working backwards gives you a much easier way of solving the problem rather than going frontwards. So if you go front, it would always be like, okay, you're gonna go from A to B to C to D, and you would have to create a lot of permutations and combinations and things along those lines. But if you solve it with DP, the solution is straight up clear. So let's get started. So with I, you start with n-1. Now you go all the way to 0, and then you decrement I, because you're going backwards. And then let's extract the points, right? Points, right? So points points would be equal to question of I of 0. And then instead of Brainpower, let's just call it jump, because that's the number of questions that we're actually jumping. So it'll be questions of I of 1. Right. So at this point, your DP of I would be equal to points, right? But the thing is, you also need to account for the question that you might have solved for it on the right side. So it would be int next question would be equal to mat.max of, so you're basically trying to get what would be the next question that you're going to solve, or n. So the reason why you're taking a maximum of n is because sometimes, like in this case, right, if you solve the 4th question, you cannot solve the next 5 questions, but it exceeds the array. So that's the reason why you need to take a minimum, not a maximum, right? So once you have that, you would say DP of I, you've already assigned the points that you'll get for solving that question, but you should also increment it by the value of points that you could have gotten, that you will get if you solve the next question that you're allowed to. And the next question you're actually allowed to solve is calculated using this. So it will be DP of next question. Next question, right? Okay, awesome. Once you've assigned the value, the next thing that you need to calculate is that, does it make sense for us to actually solve that question or to actually skip it, right? So the way we'll be calculating that is DP of I would be equal to mat.max of DP of I and DP of I plus 1. So what exactly are we doing here? So here, actually let's write this down. So this would be solve it, this would be skip it. So what we're trying to calculate here is, hey, does it make sense for us to actually solve it, or does it make sense for us to skip it and actually do the next problem? So that's the reason why you're taking the maximum of the current or the next one. So that way you'll always be tracking the maximum, and in the end you just need to return DP of 0, because that would always store the maximum value, because you come all the way backwards. So since we're going from right to left. Awesome. So let's try compiling this and see if it's okay. Oh, why? Oh, right. Of course, it's not an array. All right, let's try that again. With the first few test cases are okay. One test case seems like it's like an overflow problem. So I think usually, like, let's try that. Oh, that's awesome. Okay, so the other thing that you need to keep in track of, I don't think it's a problem with interviews, but it could possibly become a problem in like competitive programming questions. So you need to keep a track of the maximum value that you need to store in the data structure that you're initializing, so you can initialize it to the right data type. Awesome. So let's talk about the space and the time complexity. The time complexity of the entire solution is O of n, since you have to iterate through all of the values in the questions array. And it would take like O of n time. Space complexity is also O of n, since we are using an additional data structure to keep a track. Awesome. So that's how you solve this question. If you have any problems or any questions, please let me know in the comments below. Don't forget to subscribe to the channel and like the video. It definitely keeps me motivated to make more videos. Thanks so much, and I'll see you folks in the next video. Peace.